Imagine a world where energy is infinite, clean and cheap, where the power of the stars themselves is harnessed to light our cities, power our homes and drive our industries. What if we fully harnessed nuclear fusion for energy? It's not just a science fiction dream, it could be our future. But what would it really mean? Nuclear fusion is the process that powers the sun and all the stars in the universe. It's the fusion of light atomic nuclei, like hydrogen, into heavier nuclei, releasing vast amounts of energy. If we could replicate this process here on Earth, we'd unlock a virtually unlimited supply of energy. Unlike nuclear fission, which splits heavy atoms like uranium and produces long-lived radioactive waste, fusion is cleaner. Its fuel isotopes like deuterium and tritium can be extracted from water and lithium, which are abundant and widely available. And fusion's byproduct? Helium, an inert gas with no harmful radiation. But why is this so hard to achieve? For over half a century, scientists have tried to crack the code of fusion. It's a delicate dance of temperatures, pressures, and magnetic fields. We need to recreate conditions found in the heart of a star that's over 100 million degrees Celsius. To put that in perspective, it's nearly 10 times hotter than the core of the Sun. Containing something that hot in any material structure is nearly impossible. Instead, scientists use powerful magnetic fields to create a sort of magnetic bottle to contain the plasma. The world's largest fusion experiment, ITER, currently under construction in France, aims to demonstrate the feasibility of fusion as a large-scale and carbon-free energy source. But let's take a step back and think about what it means if we actually manage to harness fusion. Picture this. No more fossil fuels, no more oil spills, no more smog-choked cities. A world where energy is so cheap and clean that it's practically free. A world where developing countries leapfrog straight to fusion power, bypassing the era of coal and oil. Imagine the geopolitical shifts when oil-rich nations are no longer in control and the power dynamics of the world are transformed. Yet it's not just about the environment or politics. There's a profound philosophical shift too. Throughout human history, our quest for energy has been a story of constraint and conflict. Wars have been fought over access to resources, economies have risen and fallen with the price of oil, and entire societies have been shaped by the pursuit of power, in both senses of the word. If fusion energy were fully realized, would we see a new era of cooperation? Would it mean the end of scarcity, the lifting of billions out of poverty, the creation of new opportunities? Or would new conflicts arise? Over technology, over patents, over who controls the reactors of the future? And what about the social and psychological impacts of living in a world where energy is no longer something we worry about? Let's explore an anecdote. In 1954, Lewis Strauss, then chairman of the United States Atomic Energy Commission, famously predicted that nuclear power would make electricity too cheap to meter. His vision was wildly optimistic, but it speaks to the hope that energy, at its best, could become an unlimited public good, like sunlight or air. If we achieved controlled fusion, Strauss's dream might finally come true. But are we ready for the world it would create? Science fiction has long imagined this reality. Think of the futuristic cities powered by endless energy in films like Star Trek or The Expanse. There, fusion isn't just a power source, it's the bedrock of interstellar travel, colonization, and new forms of life. Could we be on the brink of such a transformative leap? Or will our own societal, political, and economic structures prevent us from truly capitalizing on this monumental shift? Right now, some of the brightest minds on the planet are working to turn this dream into reality. At MIT, the Spark project is racing ahead, using new superconducting magnets to make smaller, cheaper fusion reactors. Meanwhile, private ventures like Helion Energy and General Fusion are betting that smaller, agile companies can achieve what governments have struggled with for decades. Yet, let's not forget the cautionary tales of past technological revolutions. When electricity was first harnessed, who could have predicted the issues of climate change or electronic waste? So, while the potential of fusion is tantalizing, We must also consider its ethical implications, its regulation, and who will benefit from this new age of energy. To answer the question, what if we fully harnessed nuclear fusion for energy? The answer is both simple and complex. The possibilities are almost limitless, but they are only as positive as the systems we build around them. We could usher in a new age of clean, unlimited energy, or we could create new challenges and inequities. One thing is clear. The journey to harness fusion is as much about humanity as it is about science. So, will we rise to the challenge, or will we stumble? Only time will tell. Until next time, stay curious.